Hello everyone, it's March 14th. Jesus. Another late night. A full day of work. Barely any stop. And actually I had a few stop along the way, but very intense, and submit a PR. The second, I think. The second one. The second biggest, I think. Probably it's the biggest. I don't know. Because I did a very, very big one during internship. But that piece of code is guaranteed not to go into production because there are a lot of because I was leaving very soon, and there were also a lot of forces against what I was doing. But it was good practice and a good exercise for me, so it was all good for me. This time it's different. This time it's a 20 file PR, which is very big, very very big, and not all of them are triple. Actually, quite a few are not involve a lot of changes, a lot of modifications in the design and everything. I will be very interested in knowing um, how the senior devs are going to respond to this. I'll be very very interested to know that. Um, 20 files, a lot of change. Anyway, I mean the dev complete is actually in 11 days. In 11 days, which means I have to go through the code review. I mean, 11 days, and then basically next week, and I have another task coming up, which also due like before the end of next week. So, yeah, it's starting to feel a little bit pressure. Oh hey, hello. Yeah, I started to feel a little bit pressure on the job, but it was okay. It was okay. And I just watched the video of Devin, the new AI tool from Cognition. So usually watch two videos. The Fireship one, which is short, kind of giving an overview of what this new AI development is. Interesting thing. But I was not that worried even while I was watching it. It was impressive that AI can do all those things already. It can build a plan, it can analyze what you want, and then search Google. Basically, they search Google for you, read the documents, and then put things together and get something to work. Impressive, truly impressive, but definitely not at the level of replacing jobs. Because no, later on, the second video was from Primogen. He gave a more nuanced take on this. Yeah, I started to realize it was not. It was impressive, and I mean there are exponential growth in this type of field in AI. So yeah, who knows? Maybe in maybe next year will be ridiculously better, just like those image things, right? Not image, the video, right? The video generation. But still, I do agree that as long as humans are still the clients and humans are still the managers, I highly doubt AI is going to replace regular devs. I mean, if AI is going to, for AI to replace regular human developers, what is needed is for the prompts and for all the documentations, right? Those are the two most important things. For the prompt to be exact and precise, which means your clients and your managers know exactly what they want and know exactly how they want it, right? And that is very unlikely, very very unlikely. And plus, you need the documentation to be correct, and that is not always the truth. So it's interesting. I do believe what Primogen was saying, that this is just like gold rush, right? It's just like an NFT. In the last few years, it was, everybody knows it's not gonna like result in anything, but you're just trying to find it's a pyramid, right? It's a pyramid scheme, and just try to find the next sucker. For AI, at least it has some value. I do agree. It has actually maybe not just some, a lot of value. But in the current moment, yeah, they are just selling to the VCs and not selling to the regular people. And I think they might even be, if you are a startup, right? There are tons of AI startup right now. If you are a startup and you just try to win some VC money and you need to have a very good looking benchmark result, what would you do? If there's like $100 million on the line, what would you do? If you just tweak your model, let it overtrain, right? Let it overtrain just a little bit, just a little bit, then you become 5% better than your competitor, just a little bit, and the next one comes up, I will just overtrain a little bit, and eventually your model will just be an overfit model for whatever benchmark it is. I'm not saying it's the case, but it feels to me, right? It feels to me just like actors, right? They're trying to get in good shape in order for a role, and then they say, oh, they don't use steroid. But man, it's like $1 million, $2 million on the line, and they tell you, I'll give you 3 months. You need to put on 20 pounds of muscle. What would you do? $1 million on the line. What would you do? And then there is a magic pill out there that you could just spend a little bit money, and then you can just get to the goal. You can get that $1 million. The same thing, I think, for these AI companies, right? You got 100 million dangling, and you just that's just overfitting a little bit, just a little bit, and we'll get there. Whether it's gonna really mount to something, whether it's gonna really be useful down the line, who cares? You get the VC money now. It's good for everybody, right? And then you hope you get either bought out. I mean, not all of those AI companies can survive. There are tons of them, right? They just want to just keep the boat floating, even though there might be holes in it. They just keep afloat until they got bought, and then they exit, and they become a success story. Whether the technology really gonna work, yeah, who cares? Like those battery companies, right? How many battery companies were there a few years ago, all claiming that they have discovered something amazing in the battery technology, and where were they now, right? I mean, it's definitely hype, very, very much hype at the moment. Because at the end of the day, right, no matter what you do, large language models are just predicting what's gonna come in the next, right? Am I wrong? Maybe. I haven't followed this for a very long time, so I may be wrong of what LLM has turned into. Well, they can solve legal problems for sure. I know that. But hey, we don't do this for anything. We do this for the fun of it. It's a little bit late, so I think I'll just work on this. I do have some idea for this problem. Okay, I have an idea. It came to me while I was showering today. Okay, so the idea is called the monotonic array. So we're gonna do monotonic decreasing array from right to left and left to right. So I think that is how you solve this problem. Yeah, that's how you attempt. Well, I mean, there are many layers to this problem, right? You have to first find the prime score, right? And then you use the monotonic array. I can find the range for each number, okay? Find the range for each number. And then I can sort it. Right? I can sort it, and I can go from the biggest value, right? I go from the biggest value, and then try to see how many they can do. And then we got the second biggest, I can see how many they can do, and then eventually we can get to the result. So that was my idea, monotonic array. So we're gonna try this, but definitely not today. Today, I think we're just gonna go with this, and then we call it. Okay, we're gonna do a binary subarrays with sum. Given a binary array and an integer goal, return the number of non-empty subarrays with the sum goal. A subarray is a continuous, okay. Oh, dude, it's either 0 or 1. It's either 0 or 1. Return the number of non-empty subarrays with the sum towards the goal. Okay, so let's start with DP. Okay, so DP will be the first idea because it's subarray. Usually DP will work. Actually not. Hold on, let me think again. DP, well, DP will be, I say DP, DPI is the number of subarrays, okay? Number of subarrays adding to Go from nums all the way to I plus 1. Okay, one inclusive. Okay, so if that is the case, then what we want to return is dp, just len nums minus 1, right? This is what we want to return. But to compute dp, if I know dp 0 to, I want to compute dpi, okay? So how do I compute dpi? Dpi is ending in this. So if nums I is equal to 0, then dpi shall equal to dpi minus 1, right? Because including me, it doesn't make any difference, right? It doesn't make any difference. Actually, that's not true. That is not true, because including me is different. So everything, so dpi minus 1, no, ending at I, right? Ending at I. So yeah, so dpi shall equal to dpi minus 1, right? Because it's equal to 0. But I feel I am misinterpreting something. So subarrays, how many are there? Oh, ending at, so the answer is not do this. The answer is dp 0 plus dp1 plus plus dp, we call this n minus 1. That is the answer. That is the answer. But if it's equal to 0, if it's equal to I, then it will equal to whatever. So it's ending at this, right? How many subarrays are how many subarrays are like that? It's going to be, if it's equal to 0, then dp will equal to this. And of course, first of all, we need to check if the current one will suffice just by itself, right? By itself, well, what is suffice? So we check by itself what is suffice. If it is, and then we say we'll have the go minus this. Go minus this. The go minus this. Yeah, so dpi if it's 0, if else, right, if dpi, if num I is 1, okay, num I is 1, then I need to find, what do you need to find? When you find things that add up to go minus 1, right? When you find they add up to go minus 1. And then, if that is the case, if I'm 1, then if I want to say ending at me, then the 1 in front of I cannot say it's not dpi, because that will be the total number of subarrays, right? Total number of subarrays ending in here that can add up to whatever value, right? The goal value. But if you include me, that will become bigger, right? That'll become bigger. So I need to find maybe, hold on, let me think about another thing. Let's just go through this first. Okay, 1 0 1 0 1, because there's only 1 and zeros, right? So to get to the goal, we need at least certain number of 1s, right? I need certain number of 1s. So I can just go from the start and go find the first range, right? Find the first range that contains the target number of ones, right? And of course, it's gonna be from the start until a certain value, right? We have that number of one, or we can actually get the one out, right? So we have one at the position 0, 2, 4, right? We have 0, 2, 4, right? And the goal is 2, which means in this case it's gonna be, has to include at least 0 and 2, right? So at least 2 of them. Like including this, how many different ways? There's only one way to include this, right? So it's gonna be like a sliding window. Like this is the first window, and this is the second window. So when we do 0 and 2, if we only include 0 and 2, then we can count, because anything in between is gonna be zeros. So what we're gonna do is to find the gap between these. 4 minus 2, so we have 2. Actually, we should do this minus and minus 1, so we have one gap, right? We have one gap, which means we can include in this and plus 1. So we have, this is a 1 plus 1 for this gap, for this range. All right, next we'll move on to this. Again, we have 1, and then this is a gap, we have 1. So in total, this one, 1, 2, 3, 4, we have 4, right? We have 4. And when it's 0, that's a special case, right? That is a special case because you don't have 1. I can actually add these to the end. Then we'll always have something to the left, we'll always have something to here, right? We just go from here to here, and then we'll group the sliding window, and then we just keep sliding until we hit the end. So what about 0? Well, 0, we need to find, then we have nothing, right? When we have nothing, it's going to be empty array. So it's going to be minus 1, 2, 3, 4, 5, and a 5, right? We don't have these two. We don't have anything. So once, because we don't have any 1s, so we have nothing. And then we need to go through this. It's also nothing. And since it's nothing, that's a very special case, isn't it? I mean, what if it's 1? Go is 1. Then we'll have whatever is in there, and then we have a value, right? Then we have a value here. And then because it's a 1, so the left and right will be pointing just to this. Then we'll have however many on this side. Yeah, let's just say we have a 0, let's say 1, 0, 0, 0, and our goal is 1. Okay, so now 0, 1, this is B1, so we have minus 1, 1, and 5. So our ij, I equal to j, this is 0, 1, 2, right? Equal to 1, and then I check this. So to the left, I have 1, right? To the left I have 1, and to the right, 5 minus 1, we have 3. I have 3. So in total, the subarray, because I can have anyone in here, including me, okay? Including me. So I can actually do this, it should be 2, right? Yeah, that'll be 1 times 2. Yeah, it'll be 2 times. This will be a 4. So this answer should be 8. Let's just give it a shot. I want to see if this is right. So we're talking about 0, 1, 0, 0, and a 0. And this is 0. Is this 8? It is 8. So how do we handle 0 then? What if it's a 0? Then we don't have anything. So yeah, I think if the goal is 0, that's slightly different. Yeah, the goal is 0 is different, because if the goal is 0, you will have to basically say you'll have to find a stretch of 0, right? Any stretch of 0, and it has to be consecutive stretch of 0. So for the goal is 0, I don't know, like, can we unify the two? I mean, for answer is 1, it's pretty straightforward. I already have a solution for that. But for the answer is 0, it becomes very uncertain, right? Basically, it's just you want to find a stretch of 0. If it's going to be 0, you find a stretch of 0, and you find the next stretch of 0. And when you find a stretch of 0, you compute a total number, which is, the total number is going to be 1 plus the length, right? So the length is equal to 1 plus n times n divided by 2. So in this case is a 5 times 6 divided by 2, right? That's what this is. So it depends. Like, as long as it has a value, it has to go. Okay, so let's give this a shot. I feel like there's like two methods, right? If the goal is 0, you use one method. If the goal is not 0, you use a different method. Not very confident, but we're gonna take a look. Maybe. All right, so the idea is private, right, int solve 0. Okay, so we'll do this nums, and the goal is 0, already know. Okay, so basically we just need to find, okay, find consecutive, right, find consecutive stretches of zeros. So we can say for int actually we can say n of nums, right? And then we can say current count is 0 and rest is equal to 0. Okay, if n is equal to 0, then current count plus plus, else rest plus equal to current count plus 1 times current count divided by 2, and then current count equal to 0, reset to 0. Right, and at the end we'll return rest. So yeah, as we go, if it's 0, we add. Once it becomes not 0, the current count is a stretch. We do that, and then we reset to 0, and the next current count is, yeah. So that is solve it, right? And then we can also have int solve non-zero. Okay, solve non-zero again. We put nums in, and oh, now we can just do it here, right? Solve non-zero. We can say, you know, we can say if goal is equal to 0, and then we return solve 0 nums. Done. All right, if goal is not 0, then we need to first find the list of positions. Okay, then we say list of integer position ones. Okay, we'll call it 1 positions, because new array list. Okay, and then 1 post dot add -1 to start with, and then for int I smaller than nums, I plus plus, I smaller than nums dot length, I plus plus. Okay, and then if nums I is equal to 1, then 1 position dot add I, and at the end 1 position dot add nums.length. Okay. So we say if anyway, res is equal to 0, int I equal to 1, okay, and int j equal to 1, both are 1, right? And then we're gonna just move j forward, right? We'll move j forward, and once we get enough, then we move I forward until we hold on. So I and j will point into the same one, and then we'll go forward, right? We'll go forward, and now it will be always the same, right? So the j shall equal to I plus goal. So if goal is 1, so 1 plus 1 should be minus 1, right? If goal is 2, so I should have 2, so 1 plus 2 minus 1, yeah, so that's that. And then we say while j is smaller than 1 position dot size minus 1, right? Because it cannot go to size minus 1, the j, all right? Because size minus 1 is the actual value I added to it, so it has to be smaller than size minus 1, so it has to be here, right? While j is that, okay? And in fact, we might actually just call, yeah, why do you even do it this way? We're going to say for int I is 1, right? I equal to 1, and I plus goal minus 1 is smaller than 1 position dot size minus 1 I plus plus, right? And then we say int j is gonna be I plus goal minus 1. And then once we have that, we're gonna do some computation, which is res and then plus equal to something times something. Okay, what's this something? This something is I 1 position dot get I, its index, minus 1 position dot get I minus 1, right? That's the total number I can get on the left hand side, multiplied by 1 position dot get j, okay? Actually no, j plus 1, right? Minus 1 position dot get j. So that's the total that we can get for this window, right? For this window. And then once we're done, I move forward, j will move forward as well until we get out. And then once we get out, what we're gonna do is we'll return res. Okay, it's 31. Let's hope this one is correct. So I can go watch some YouTube videos, practice some typing, and I'll call it a day for today. Okay, 1. That's a good one. Then we can do 1. All right. We probably let's do 2. Just run them. See if they make any sense. Oh, that was not as expected. All right. The second one is wrong. I mean, the go is 0. Here, solve 0. I get what? I get output 0? That is ridiculous. Oh, shoot. You are absolutely correct. So at the end, we have a current count, right? social plus whatever the current count at the end. My bad. That was an oversight. See, that's, you have good test cases. These things are much easier. What I think the method for when go is 0 is different than from when go is non-zero. Right? When it is 0, we simply look for stretches of zeros. When non-zero, we look for we tally all the ones together and form window. Right, and form a window whose size is go. Then we look towards the left and the right to include extra zeros. Yeah. So I'll say this. Let's see if it works. It does. It does work. With I'll say it's decent performance. Okay. Definitely decent. All right. What do we do now? We go check the solution, see how it goes. Prefix sum, very interesting. That's a different idea. Prefix sum. Okay, let's see how prefix sum can solve this problem. Prefix sum, whenever we get the prefix sum, ooh, wow, it's prefix sum. I mean, I still like my method, but prefix sum can avoid using ArrayList. And I can see how prefix sum works, because prefix sum, basically you're gonna go prefix sum, you get to the first one that you have the same as go, right? Actually, no, you have to, oh damn it, you keep going on. Well, you get the first one, right, that you reach. Okay, so here's the one. Hear me out. You have the previous, previous you set to 0, and then you start going prefix sum until you hit the first time. Until you hit the first time, that is your target. Okay, that is target. But you still need to know the first one, right? You still need to know the first one. Yeah, because you start with 0, right? You start with 0. So we will go 0, 0, 0, 0, 0, 0, 0. And then the first time that it changes from your previous value, that is the marker. That's your I, okay? And then keep going. And the first time that it's, the first time that the difference between the current and the previous prefix sum is not 0, that's your left. And the first time your prefix sum minus the previous is equal to minus the previous. It's not that straightforward using prefix sum. Because if you go prefix sum, this is a 2, okay, and then this is a 3. Then you need to know where 1 is, right? You need to know where 1 is. You have to record the position. I do think you need to record the position, because everyone is 1, so yeah, you can record the position. And you need to record 2 positions, right? You have to record the position that the first time and the position of the last time that occurs. I wonder if that is exactly what they mean by prefix sum. Okay, it looks very simple. Sliding window, that's what we do. We use sliding window, but not exactly. You can do sliding window like that. Okay, so we have sliding window one pass. Mine is 2 pass. Okay, so we have 1 pass sliding window. All right. Let's see. What is this prefix sum idea? You have to collect the position. Frequency of the prefix sum. Frequency of the prefix sum. Very interesting. Okay, so you go through this, you get a prefix sum. If the prefix sum is equal to go, that's the count. That's good. And if there any prefix sum that can be subtracted from the current to get a desired goal. I see. Wow. That is pretty darn good. Right? That is pretty darn good. Okay. Okay. Yep. That's correct. You get a prefix sum, the current, and you need to know how many different prefix sum that can get you to the goal that used to be before. And for every single position, right, that's basically you're finding the total number of subarrays ending at your current position, right? And to find that, you just need to know from where the previous, okay, prefix sum is good. Oh, yeah, it's better than my solution. It's better than my solution. How about sliding window? I mean, this is almost like sliding window, but I think this talks about slightly different sliding window. I mean, this sliding window, again, if you find a stretch, right? If you find a stretch that equals to whatever you want, and then what? I mean, you start with something and you keep going, and then you go to the first one that results in what you need. Then you reduce, right? No, you keep going, right? So you have both on the left hand side. So the right pointer just keep going until the first one that hits the value is larger than what you want. Okay, so the first one that hits the value larger than what you want, then you stop, right? Yeah, then you stop. Okay, then yeah, you need to record the first time. This is sliding windows where you need to record the first time you hit. Okay, and so there'll be a left limit, a right limit, and a left edge and a right edge, right? So it's like 4. You have 4 values. And as you go through the whole thing, you go once on the right pointer, then you can collect both, and then you go the left pointer, right, and you also collect both, right? You also collect both, and use these information, you can compute the result for the current one, right? And then you move forward again. Very interesting. Yeah, we can do sliding window as well. Okay, so now is a decision to make. I think I will at least entertain the frequency. Okay, so I think the frequency is a very good one. I really like. I think it's much better than mine. So this is the frequency, right? So that's, we call it the this is the prefix sum, right, plus frequency method, okay, from the official solution. Right, it is essentially finding the number of subarrays, right? Subarrays ending at each position. Now, if we have kept the prefix sum for each position to get to the goal, we only need to know how many previous prefix sums, right, when deducted from the current one ends up with goal. Yeah. So we're gonna do a frequency. Frequency is gonna be in a set, a hash set, a map, right? So we're gonna do a map integer. There's a counter, new hash map. That's fine. And then we need to go a pre-sum, right? Pre-sum is equal to 0. And then we say int res is equal to 0. Okay. Then what we do is for int n of nums. Okay. So for each one, we say pre-sum. Let me think. Edge case, right? If this, because we need to know the frequency. Because from me, right, minus whatever it is, right, minus whatever it is, like if the subarray is starting from the beginning, right, which means the current prefix sum is what we want. So in that case, I do have to say counter.put 0. This is going to be 1. Because that's the pre-sum, initial pre-sum, and the rest is this. And then we say, okay, pre-sum plus equal to n. Okay, pre-sum plus equal to n. So this is the current pre-sum. And now I want to know how many previously. Then we say res plus equal to counter dot get all default n minus goal, right? No, not n, pre-sum minus goal. Default is gonna be 0, right? So we do that, and then we say counter dot put. We're gonna put pre-sum, and value is counter dot get all default pre-sum, and this is gonna be 0, right, plus 1. So we do this at the end and we return res. Wow, this is very, very simple. Very simple. Very simple idea. Maybe kind of don't want to do the sliding window. Okay, that's not right. My bad. There's no solution 2. Yeah, really made me not want to do the sliding window one. Typo. There's typo everywhere, man. How about you? Yeah, it was good. It was. Damn, it was slow. It was so much slower than the previous one. Wait, how is this? This is what? 54%. Oh, they have 2 peaks. All right, they have 2 peaks. So I think this peak is the, yeah, this peak is the 20 milliseconds. So we were on the fast route. This is an easy one, but easy, you have to pay a price. All right, you have to pay a price because you have a hash map involved. That was the price. Although it's still ON, you have the hash map involved. All right, So the last one, I do believe the sliding window is the fastest, but I don't want to do it today. Feel bored? Not bored, feel late. I still need to eat. So we'll have 2 questions. That's good. Tomorrow we'll get back to this one again, right? We'll do the sliding window. It's not hard. Right? Sliding window is not difficult. It's just a little bit complex. And we can do it in one pass. Yeah, we can definitely do it in one pass. All right, that will be it for today. I'll see you guys